Hello, this is Mrs. Boots, and this is our lesson on adding and subtracting rationals. Before we get into the confusing rational equations that have our x's and y's and things like that in the fractions, which always gets a little bit crazy, we're going to look at some simple fractions. And I know these aren't on your notes, but you can scribble them off out to the outside, or you can just listen, whichever works for you. Okay? I have two fractions being added. Now, what do they have to have in order to add? Yes, they must have the same denominator. The denominator, remember, is the bottom of the fraction, okay? So I have to have the same denominator. Now, when we add, do we add just the top, just the bottom, both of them? What do we do? Yeah, we add just the bottom, okay? So make sure that you know that. Add top only. What's the top called? It's called the numerator, right? So the only thing I'm going to be adding is what's on top. Now on the first one, the denominators match. They're both an 8. So I could actually go ahead and write part of my answer down. It's an 8, okay? Now on top, 3 plus 7 is 10. Now here's the other thing. We always need to simplify. Can we reduce 10 divided by 8? Yes, we can. Both numbers are divisible by 2, so this would give us 5 over 4. That would be the correct answer, or the simplified answer, all right? What about this one? So the numbers on the bottom don't match. I have a 2 and a 4, but I could multiply the 2 by something to get 4, right? Yeah, because 4 is an even number. So remember, when you do that, we multiply top and bottom by the same thing. So I'm multiplying top and bottom by 2, okay? So on top, I end up with 2 times 1. Kind of anticlimactic, I know. That's just 2, right? I still have the plus 3. On the bottom, they're both now 4. Well, what is 2 plus 3? Yep, it's 5. So I have 5 over 4. Now, I know it is an improper fraction, both of those, and your teachers probably taught you to turn it into a mixed number. Since we're going to be going straight into x's, I'm not worried about that right now, okay? Let's look at the third simple, super simple. Okay, I have on the bottom, denominators are 3 and 5. Yeah, there's nothing that I can multiply one of them by to get the other one. So this is very similar to what most people like to refer to as cross multiplication. I'm going to multiply the first fraction by the denominator of the second, and multiply the second fraction by the denominator of the first. Okay? So on top, 5 times 4, 20, plus 2 times 3, 6. On the bottom, 5 times 3, 15. Okay? What is 20 plus 6? Right, 26. So I have 26 over 15. Now, 26 is not divisible by 5, and not divisible by 3, not divisible by 15. So this is the simplified answer. All right? This is elementary school. You've been doing this a while. If you haven't, you might want to go back and review that. I don't remember if it was 3rd, 4th, or 5th grade, but it was somewhere in there. It might have been 6th grade. I guess it depends on when you did that lesson. So let's look at example 1. In this example, I have two fractions. Are we adding or subtracting? We're subtracting. It doesn't matter if you're adding or subtracting. You just carry that operator, okay? Can I reduce any fractions before I get started? Actually, in this case, we can, okay? And we want to do that anytime we can because that makes the numbers smaller, it makes our fractions smaller, it makes it easier to get things done. Okay, so I notice I have an x over an x squared. That cancels out a little bit, right? So I'm going to write my first fraction down so I don't lose track of where we are. So I have a 3, and the xy is in the denominator, minus, and this would become 9 over x. Okay? So now I have two fractions. They are simplified. They're in their lowest possible form. Do the denominators match? No. But I notice they both have a x, right? So what is the second one missing? It's missing the y, okay? So this is similar to this one, right? I only have to multiply one fraction by something. So I'm going to multiply the second fraction by y over y. Okay? So let's do that. So I still have my 3. And my 3 is minus 9 times y, and that's all over xy. Now, do I have any like terms I can combine? No. No like terms I can combine. Is there anything I can reduce? No. This is the answer. That's the confusing part. We don't get nice, pretty little numbers. Sometimes we do, but most of the time, we're going to have x's in our solutions, okay? Let's look at example 2. Example 2, we have x plus 2 and an x minus 2. Okay, so my denominators don't match. And you might say, well, they both have x's. It's just that plus 2 minus 2 thing that's messing us up. That's true. That is true. However, think of this binomial as one entire piece. Okay, it's one entire piece. I can't just break it in half. I can't multiply this one by positive 2 and this one by negative 2. It's not going to work. It's all or nothing. Okay, it's all or nothing. It's like making it to the Olympics. You either did or you didn't. There's no halfway. Okay, you either qualify or you don't. So, this case, my denominators don't match at all. There's nothing I can multiply one of them by to get the other. This is similar to our last little simple one. We're going to have to multiply both fractions by something. So I'm going to multiply the first fraction by what it doesn't have. It doesn't have an x plus 2. And the second fraction doesn't have the x minus 2. Okay? So let's write this down so it's a little neater. Okay, so we have x plus 2 times x plus 4. Then you've got that plus sign. Okay, then we have the 7 times the x minus 2 all over x plus 2 times x minus 2. Now here's where I have students who go in and they're like, oh, cancel, 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 cancel. Boom, done. No. We have to multiply and simplify, okay? So on the top, yes, we are going to do our double distribute on those two binomials, and we're going to distribute on that second one, all right? We're going to distribute it all out. I'm not going to write the denominator again until I get to the answer, just so I can save space on my paper or board. It works better that way. So I have x squared plus 4x plus 2x, and then 2 times 4 plus 8. All right. Now this is a plus 7, so I can distribute that. And I get 7x minus 14. Now let's combine like terms. How many x squareds do we have? Well, we just have the 1, so that's easy. All right, let's see. We got an x, and an x. So I got 4 plus 2 plus 7. 6 plus 7 is 13. So I have a 13x. And then it looks like I've got an 8 minus a 14. What's that going to be? Yeah, minus 6. Now remember, that's the numerator. That's the top. So I got to put that over what was in the denominator, x plus 2 times x minus 2. There you go. Now, at this point, yes, I might see if I can pull a GCF out. I might see if I can factor this and cancel. But most of these problems, you won't be able to. Let's look at a few more. Example 3. I have two fractions again, two rational expressions. The denominators don't match. And my denominators have to match in order to add or subtract them together. Okay, so instead of just going ahead and multiplying the other ones and doing all that, let's double check something. This is an x squared. This one's just an x. I would recommend that you factor anything out, a GCF or an x squared, because it may give you a simpler least common denominator. Okay? So x squared minus 9. That looks familiar. Isn't that one of those perfect square things? Yes, it is. I have my x's in front, a plus and a minus. What squared gives me 9? 3. So I have an x plus 3 and an x minus 3. Okay. Now look. They both have an x minus 3. But one of them's missing the x plus 3. Okay. So this is like Grandma with the cookies, right? She's handing out cookies. Everybody gets one. And one grandkid got 2. So guess what? Everybody has to have 2 cookies. Otherwise, we're going to have a fight on our hands. And Grandma knows it. So Grandma gives everybody 2 cookies. Mom and Dad would tell you to stop pouting or go to your room, right? But Grandma likes to give out the cookies. We are going to play Grandma. So we're going to give the second fraction what it doesn't have. It doesn't have the x plus 3. We're going to give it that x plus 3. We won't even charge it any money for it, okay? So now look at the first fraction. Did we have to multiply by anything? No, we didn't. So we're just going to write it down. 4x minus 3. I'm going to bring down the sign that's in between my 2 fractions. Minus. Make it nice and big and bold so I don't forget it. Now I have 2x minus 3 times x plus 3. We're going to have to do something there, aren't we? But yeah, we got 2 things we got to do. We're going to have to distribute this negative sign over, right? But we got to FOIL these things out first. We got to multiply them out. So let's do that first. Let's do our multiplication. And then we'll go through and distribute that negative sign. That'll be easier. Okay, again, my denominator should be written underneath. I'm not going to write it to save space. I'm just going to write it at the end. What is the denominator? This is my denominator. This is my least common denominator. Okay? And we know that, and we see it, and we know what's going on the bottom. All right? So let's keep going. 4x minus 3 minus, I'm going to keep that minus out front. Let's multiply. 2x times x, 2x squared. 2x times 3 plus 6x. Negative 3 times x minus 3. Negative 3 times positive 3, negative 9. All right. Got some like terms we can combine, right? Yep, we do. So I got 4x minus 3. Do you have to combine them right now? No, you could distribute the negative. 2x squared minus 6x plus 3x plus 9. Remember, the negative changes the sign of everything after it. Now let's go through and combine like terms. X squared, only got one of those, write it down. X's. I have a plus 4, a minus 6, and a plus 3. Okay, well this gives me minus 3. 4 minus 3 is 1, so it's plus x. And then I see I've got a negative 3 and a positive 9. So 9 minus 3 is 6. Okay, so I got negative 2x squared plus x plus 6. Do I just put a box around it and I'm done? No. We have to bring the denominator down. Now, I could have written the denominator underneath each and every step. This is where mathematicians and scientists are lazy and where we try and save paper. This is my answer, okay? We're not going to factor out the top. We're just going to keep it like this, okay? Let's look at example 4. What do we got? Yeah, we got the same thing again. This is getting you, huh? We're going to have to factor this. Anytime you see an x squared, think, I should factor that and double check it. Okay? So I need 2 numbers that multiply to give me 18, my constant. And they're going to subtract, because that's negative, to give me 3. Well, 9 times 2 is 18, but when I subtract them, I get 7, so that's not going to work. 6 times 3 is 18. Okay. When I subtract that, 6 minus 3 is 3, so that works. Let's write that in. So we got x minus 6, x plus 3. How do I know the 6 is negative? Because it's the bigger number. Remember, the bigger number gets the same sign as the middle. Here's the interesting part. With adding and subtracting rationals, most students understand the theory and the concept. Where they make their mistakes is in the factoring. That's why we did that whole lesson on factoring. Okay, what do they both have? They both have x minus 6. All right, so what's missing? Remember Grandma with the cookies. Who'd she miss? X plus 3. She's got to give out the x plus 3 to this poor little fraction over here. He's crying because he didn't get one. All right, so we give out the x plus 3. Now they both have the same amount of cookies. They both have the same amount of factors in their denominator. So we can move forward. Let's bring it down. I got 2 times x plus 3. Oh, big old negative sign. And then a 9x. Okay? What's the least common denominator? The least common denominator is both of them put together. X minus 6, x plus 3. We'll tack it on at the end. Let's do our little distribute here. And we will simplify. So I got 2x plus 6 minus 9x. Okay. Got some like terms we can combine. I see a 2x and a minus 9x. What's that going to give us? Minus 7x plus 6. Okay, not done. Got to write the denominator in there. X minus 6, x plus 3. Again, if you are afraid of losing that denominator, that's okay. Just write it underneath each and every step. All right? Example 5. Example 5 is actually just like examples 3 and 4. They have something in common in the denominator, but it's a little hard to see at first. When you first look, you'd think, oh, I have an x minus 2 and a 3x minus 6. They're not going to match. But isn't 3 and 6, aren't they both divisible by 3? Yeah, they are. So let's plot a GCF. And I get x minus 2. Crazy. Yes, teachers actually plan it so it works like that, okay? So they both have an x minus 2. So what most students normally do on this problem is they multiply the second one by x minus 2 and the first one by 3x minus 6, and we end up with all these x's everywhere, and then it's just a mess, okay? All we need to do is multiply the first one by, 3. Now they match. Isn't that beautiful? They match. Okay, so on the top, let's write down what we got all the way across. Okay, so I have a 3 times 2x minus 7. Bring down that sign in between the fractions, please. And you have an 8x. Easy enough. Now I could write my denominator underneath 3 times x minus 2. Okay, that way I don't lose it. And that's okay, all right? Let's go ahead and distribute. This beautiful 3 needs to be distributed so that we can simplify and combine like terms. So 3 times 2 is 6, so 6x minus what? 21, very good, plus 8x. All right, I can combine two terms. I can combine 6x and 8x. What do we get? Very good, 14x minus 21, okay? And then I have 3 times x minus 2. Well, some of you may be saying, hey, that looks really similar. Okay, so just side note, let's try it, all right? If you pulled out a 7 from the top, you'd have 7 times 2x minus 3. Is 2x minus 3 the same thing as 3 times x minus 2? No. So they're not going to cancel. It doesn't reduce. This is my answer. You're like, okay, businesses do this. They have a model for one thing and a model for the other thing, and they have to add the two of them together. If you program them separately, it takes the computer twice as long to process all the information. So you want to take it and simplify it to one expression and program that, because then the computer is going to take less processing and less memory. You're thinking, oh, it's no big deal. We got processor memory galore. It's not a problem. Yes, But when you're dealing with tens of thousands and millions of pieces of information, it gets to be a problem. Okay, example 6. Now both of these are on the back. Example 5 is actually top right problem. And then 2 problems underneath that is example 6. I gave you plenty of examples with the answers so you can work through and see if you can get them. I'm not going to cover all of them in the notes because I think that would be a little painful. All right, but let's look at number 6. What's different about number 6? Yeah, I know, crazy lady, come on. I got 2 trinomials, 2 x squareds. That means I got to factor both of them. Yeah, I know. Life's crazy, we do that. So I need 2 numbers to multiply to give me 20. And they were going to subtract to give me 1. You got it, 4 and 5. Okay, so I got a 5, I got a 4. Which one's positive? 4, 5's negative because it's bigger. Middle sign is, okay. Now I got 12. What multiplies to give me 12? 3 times 4 is always the obvious one, and yes, they add to give me 7. So I have x plus 3, x plus 4. Yeah, you're laughing now because you see it. They both have x plus 4. Okay, so how does this one work with Grandma and cookies? There's 3 kinds of cookies, right? We have chocolate chip, we have oatmeal, raisin, and then let's say coconut macaroon. Well, they both have a chocolate chip. This guy's got the coconut and this guy's got the oatmeal, and they each want one of the other. They want all 3 cookies. One of each kind, not just 2 each. Everybody wants one of each kind. I remember my mom used to divvy up the M&Ms by color, and everybody had the same number of colored M&Ms, same blues, same reds, same greens, and she would eat the leftovers because as little kids, it mattered. She's got more blue ones than me. They all taste the same, but she humored us. So what is the first one missing? It's missing an x plus 3. So I'm going to multiply by x plus 3. Because there's not a lot of room, I'm going to write it over here on the left in the denominator. So second fraction, what is it missing? X minus 5. So I write in x minus 5, top and bottom. Now, they both have all 3 kinds of cookies. They both have x plus 3, they both have x minus 5, and they both have x plus 4. All right, so now we're ready. Now we can proceed. Write down the top, the numerator, x plus 2 times x plus 3 plus, got to get that sign in the middle, don't forget it, 3x times x minus 5. Otherwise it becomes one big, huge, monstrous multiplication problem, and we don't want to do that. All right, so now we can do some distributing. We know the 3x, that's the easy one, right? And then we got 2 binomials. I know, we've been doing this since 5th grade. All right, x times x is, x times 3, 2 times x, 2 times 3, and now 3x times x squared, and 3x times negative 5. Crazy. Now let's look at what matches. Okay, like terms, I have an x squared and an x squared. X squared, 3x squared gives me 4x squared. Okay, I have a 2x and a 3x and a negative 15x. Okay, 2 plus 3 is 5. 15 minus 5, negative 10x. And then we got the poor little lonely 6 that's left, so we just tack him on the end. Okay. You could go through and pull out a 2, right? But it's not going to factor to any of that mess. So we're just going to write it down. We've got to write all 3 of them. X plus 3, x minus 5, x plus 4. Does it matter which order I write these in? No, it doesn't matter as long as I remember to include all of them. Okay, we have one more example. And it's example 7. This one's a little bit more challenging. And at the same time, it's actually just as easy. Yes, we have 3 different fractions. This is the very last example on your page. 3 different fractions. 3 different denominators. But are they? Look at the middle one. It's got an x squared. Sneaky, sneaky. We have to factor it. Isn't 4 a perfect square? Yes, so I'm going to have an x plus what? 2 and an x minus 2. Oh, okay. I see what's going on. So notice the first 2 fractions have the x plus 2 and the second 2 fractions have the x minus 2. So again, this is kids with 3 cookies. He's got one, well, 2 cookies. He's got one, she's got one, and this person got both of them. So the other 2 kids are mad. They want both of them too, right? So which factor is this fraction missing? Which cookie do they get? They get the x minus 2. Last fraction's missing a cookie. Which one does he get? Yep, x plus 2. Now they both have, all 3 of them have both cookies. X plus 2, x minus 2. All right? Let's write down the numerators because we got to simplify all this mess. So we have an x minus 1 times an x minus 2. Plus, bring down that sign, please. There's a 4 on top of that fraction. Plus, bring down that sign. 6x times x plus 2. Now, a common mistake that people make before they ever get to this point, and I forgot to say something sooner. Notice the middle fraction has 4's top and bottom. I have some very brilliant students who just cross them off. Oh, they match. They cancel. 4 divided by 4 is 1. Done. No, that 4 is attached to an x squared. Think of it as a happy couple. They're holding hands and you just broke them up. You heartbreaker, you. Okay, we're not doing that. We're not heartbreakers. We're very compassionate, loving people. We don't heartbreak our fractions. So let's keep it together, please. All right, so now we can, we've had a life lesson there, proceed with the simple stuff, which is math. It's always easier to do math. Okay, there we go. Factor, factor. No! Distribute, distribute. All right, x times x. X squared, x times negative 2, negative 2x, negative x, and positive 2. Bringing down that positive 4 so we don't forget them. Now I have a 6x squared and plus 12x. Easy enough, okay? X squared's got to combine like terms. I have an x squared and a 6x squared. That gives us what? 7x squared, very good. Now we have the fun stuff. We have a minus 2x, a minus x, and a plus 12x. Okay, so this is minus 3. 12 minus 3 is 9. So I have 9x. And then I have my constants. 2 plus 4, 6. Now what do we put on the bottom? X plus 2, x minus 2. Gotta have both of them. There we go. This concludes the adding and subtracting rational expressions next.